Hello everyone. Today let us discuss about another module of our digital filter design course, that is the IIR filter design using direct form one structure. Now IIR means it is the infinite impulse response filter. Now once again I can specify that IIR filter is nothing but one recursive system. So what is the recursive system? It is nothing but when the current output depends upon the current input as well as the past input and past output, then it is called the recursive system. But in case of IIR filter, it is called a non-recursive system. So non-recursive system means when the present output depends upon only the present input and past input. So now here we are going to specify two more criteria of designing any filter. So if the impulse response of any filter, if the impulse response is denoted by Hn, then we must be assured that Hn should be equal to 0. First criteria is Hn should be equal to 0 for all n less than equals to 0. And the second one, the second condition, which in the context of stability of any IIR filter, it should be that the summation of impulse response for all the time value taking from 0 to infinite should be always equal to finite. Now keeping this two in our mind, we are going to realize one IIR filter with its DF1 structure. Now let us start from the transfer function. So going to define once again the transfer function of our digital filter called IIR filter. So it is very basic formula of yz xz equals to yz by xz. So that is the output response and input response in its frequency domain. Take the ratio, it is becoming the transfer function. Now once it is taken in terms of coefficients, it will be summation over k equals to 0 to m bk z to the power of minus k by 1 plus summation over k equals to 1 to n ak z to the power of minus k. So these are nothing but the transfer function. Now what is required at this stage? We have to get the difference equation of the respective system. So respective system is the IIR system. Now the difference equation can be obtained from this equation number 1. If this is equation number 1, directly by taking the inverse Z transformation along with the time shifting property, we'll get the difference equation as here it will be yn is equal to minus of summation over k equals to 1 to m k equals to 1 to n ak y of n minus k plus summation over k equals to 0 to m bk x of n minus k. So this is nothing but the difference equation for the given transfer function. Now what is to do? We have to expand this particular equation. We have to expand this particular equation to expanded form. Now after expanded form, we have to get the value of yn. Output response will become here minus of a1 yn minus 1 minus a2 yn minus 2 plus dot 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 will be up to the n number of terms are there, 1 to n, so it is n number of terms will be there. So an y of n minus capital N. And similarly for the second part of the equation, it is b0 of xn plus b1 of xn minus 1 b1 x of n minus 1. So it will be continued up to bm. So m plus 1 number of terms will be there. So bm x of n minus m. So this is nothing but the equation called the difference equation. Now this difference equation are to be taken in a particular in a specific way to have the break of we have to break this difference equation into two different parts. So these two parts are taking this is the second part of the equation, that is b0 xn plus b1. Say this is equation number here 2. So b0 xn plus b1 x of n minus 1 bm of x of n minus m is equals to, say here another DTS called wn. Now this dts, if it is wn, so accordingly we can replace the value, we can replace this equation number 3 using equation number 3 into, we can have that yn is equals to nothing but it is minus of a1 y n minus 1 minus a2 y n minus 2 so on, and accordingly it is minus of an y n minus n, and the lastly it is plus wn. So equation number 4. Now it is very easy to understand. We have got here 4 equations. Now out of 4 equations, last 2 equations will be used in realizing our structure. So do remember that we are taking equation number 3 and equation number 4 for realizing the structure. Now accordingly, what will be the structure? Try to understand. Here I need some space. So accordingly you just get here xn is the input, and we have to use some, so xn should be the input for equation number 4. So we are talking about, right now we are talking about the equation number 3. So equation number 3, it is xn will be the input and wn will be the output. So wn should be the output, and then you take we have to take along with xn, we need all the components of x of n minus 1, then x of n minus 2, like that. So we must use some adders to add all these time shifted versions of the action. So accordingly we are going to take all the x of n minus 1, then x of n minus 2. So take one more delay element here to obtain x of n minus 2. In this way we'll get the second, we'll use another adder here, and that will be taken here. So this is nothing but, and accordingly you must remember that we have to use all the multipliers properly. This is here b0, then b1, this is b2, and lastly we have here x of n minus capital N, and it should be added with the previous stage, and accordingly this is the nothing but Bn. So this is the part of the equation number 3, and when equation number 4 is realized with the help of that same kind of adder and delay elements, it will be like this kind of structure. So Wn, definitely Wn is the input for equation number 3, and this equation number 3 when taken along with the adder, and so output will be there yn, and after that we have to take the time shifted version, time delayed version of yn as of y n minus 1. That should be taken on the previous adder, it should be added there, and as we need y n minus 2, go for the second delay element y of that will give you y of n minus 2. So it is nothing but y of n minus 2. Same way you just add here, and this will be continued up to the m number of terms. So this m number of terms will be now again finally added with the previous stage. Now this is nothing but the expression of the equation number. So this is nothing but equation number 4 and relation of equation number 3. Now these two when cascaded, these two equations are when cascaded. Before that you must notice that we have some multiplier factor here also, minus a1, minus a2, and minus of an. So these are multiplier gain factors are to be used properly, and when added with the in the final stage what is to do, it is simply you just connect the wn from the first stage to the wn of the second stage, and that will give you a structure called direct form 1. Thank you.